Let's look at how to solve some natural logarithmic equations. Here we have the natural log of x is equal to 2. So I notice I just have a single logarithm, and that single logarithm is isolated. It's the only thing contained on the left side of the equation. Since that's the case, I'm ready to go ahead and convert this to exponential form. To be able to do that, you have to know what the base of the natural logarithm is. So we said that was e, so we will do e, and then jump across here to get your power to the second power is equal to x, like that. And then you need to go to your calculator to evaluate what e to the second power is and round to the appropriate number of decimal places that you're asked for in the problem. Going to the calculator to evaluate e to the second power. If I look down here, here's the natural log key. You see there's an e to the x right above that. So if I do second and then the natural log button, it'll bring up the e to a power. I can go ahead and type my exponent of 2 and hit equals, and I can see that decimal equivalent of e to the second power for that. And I believe this problem is asking me to round to the nearest thousandth, which is 3 decimal places. So this would be 7.389. This 0 would leave this a 9. So 7.389 would be the solution to this equation, rounded to the nearest thousandth. Taking a look at this example, natural log of the quantity x minus 3 is equal to 4. We want to go ahead and solve this natural logarithmic equation. First thing I want to just comment on is, since I see something with a variable inside this logarithm, remember I can't evaluate the natural logarithm of something equal to 0 or something negative. So what's inside here has to be greater than 3 for that to be the case. Anything less than 3 or equal to 3 would either produce 0 or a negative inside this logarithm and therefore make something that was undefined. So knowing that x has to be greater than 3 before I even start solving this problem is always good to have in the back of my mind in case I get an answer that's not greater than 3. I know to throw it out for that. So now let's go ahead and look at how to solve this. Let's convert it to its exponential form. The base of the natural log again is e, so this would become e to the 4th power. E to the 4th power equals x minus 3. And then I have one more step of algebra to solve this for x. I need to go ahead and add the 3 to the other side. So this will become e to the 4th power plus 3 is equal to x. So there's the exact answer to that if you wanted the exact solution. If the directions ask you to round to a certain number of decimal places, then you'll go ahead and go to your calculator to evaluate e to the 4th power plus 3. So let's do that now. Going to the calculator to evaluate e to the 4th power plus 3. So I will go second and then my natural log key to get e to the 4th power. Make sure I get my cursor out of the exponent if you have one of these new fancy calculators. And then finally plus 3 equals, I'm seeing 57.5981, so rounded to the nearest thousandth would be 57.598. Let's look at one more example of this. Here we have natural log of the quantity 3x plus 5 squared is equal to 4. We don't have to be quite as careful with the values of x here because I'm taking this and squaring it. I know that I'm not going to end up with any negative numbers, so the only thing that x couldn't be would be anything that would make this equal to 0 in here with that. So if I went ahead and I solved that, figure out what x couldn't be, I would have negative 5/3. So as long as x isn't negative 5/3, I'm good here. Any other values of x should be just fine for this one because of the squared. So let's go ahead and solve this. Again, I do just have a single logarithm there. So I'm going to go ahead and convert this to the exponential form right now. The base is e. So I do e to the 4th power equals the quantity 3x plus 5 squared. Now, as I go to solve that for x, I need to go ahead and get rid of this second power. I'm going to cancel that second power out by taking the square root of both sides. Again, remember the square root is just a 1/2 power, so if you take power to a power, you multiply. So this will become e squared. But since you took the square root of both sides, you technically need plus or minus there. Is equal to 3x plus 5. That's a little bit of a shorthand. Technically, this is equal to the absolute value of 3x plus 5, when you take its square root, and then when you solve an absolute value equation, you set it equal to the positive and the negative. That's where that plus or minus symbol is coming from. So now I need to go ahead and continue working to solve this equation. To get x by itself, I need to get the 5 to the other side by subtracting it. I would write it out in front of the plus or minus symbol, like that. So I have negative 5 plus or minus e squared is equal to 3x. And then finally divide both sides by 3 to get negative 5 plus or minus e squared, all divided by 3, is equal to x. So there's my exact solutions to this, 2 of them, one with the plus and one with the minus. So if I wanted the exact solutions to this problem, I'm done. If I wanted the approximate decimal solutions rounded to a certain number of decimal places, I would go ahead and go to the calculator and compute that. So let's go ahead. Going to the calculator to evaluate, I need to do parenthesis negative 5 plus e squared, close my parentheses, divided by 3. And there I can have one of my solutions, and then I need to work the other one with the minus, negative 5 minus e squared, out of the exponent, close my parentheses, divided by 3. There's my other solution. Rounding those to the nearest thousandth, 3 decimal places, I would have 0.796 and negative 4.130. The 6 would force this 129 up to 130, which you could get away with just saying negative 4.13. That would be accurate to the nearest thousandth, even though it only had 2 decimal places typed, because typing the 0 would be unnecessary. So that's how you do that.